world, they do actually believe in the assumption of homology, and they also, prior to that, have the assumption of methodological naturalism. Now, Elliot Sober, who is an atheist, again, evolutionary biologist, if you don't dispute he's an atheist, we can deal with that too. He's an atheist evolutionary biologist. In his book, Evidence and Evolution, which is published by by Cambridge University, he says, the idea that humans and chimps must share a common ancestor because they're so similar, and humans and mushrooms must have independent ancestry because they're so different, they're both naive, because within a probabilistic framework there is no must. And he goes on in that same very book speaking about homology, homoplasy, and the ad hoc rationalizations which do actually exist in the field of evolutionary biology.
You're misquoting Elliot Sober.
Wait, hang on one second. So what I want you to do is this. I want you to show me that scientists don't begin off with the assumption of homology. Don't take a word of a scientist out of context. I want you to show me as a field they don't begin off with the assumption of homology. And two, I want you to show me how it's possible to have a conversation about homology without speaking about the mechanism, because if you can show all the similarities between humans and chimps, humans and pigs, humans and whatever, if there is no mechanism of transformation, all you have is a story. Which is why, and this is the last point I'm going to make, you can try and refute all these points, human-chimp ancestry was something which the ancient Greeks believed in, the ancient Hindus believed in, the Enlightenment Victorian thinkers also believed in, including Darwin and his grandfather. The reason why this idea took off is because Darwin gave a mechanism, the mechanism of natural selection. If the mechanism breaks, or if the mechanism is shown to be insufficient, you cannot claim human-chimp ancestry is true.
Okay.
Because without the mechanism, it's like you have a bridge and you have two foundations, the foundations break and you want to cross the bridge. You cannot. Darwin's theory is not a theory about similarity, it's a theory about natural selection leading A to Z.
Okay, all right, so what Suboor did was totally and utterly misquote Elliot Sober. Okay, so what he said was true, that Elliot Sober says you can't just look at similarities and then derive common ancestry. That's naive, and I agree with that. I agree with that right from the start, right? But what Elliot Sober goes on to say, don't interrupt, what he goes on to say was, and this is a direct quote, you can look this up in that very book, the torpedo shape found in sharks and dolphins does not provide strong evidence for their having common ancestor. Natural selection favours this shape in large aquatic predators, so we'd expect it to be present in modern sharks and dolphins regardless of whether they have a common ancestor. In contrast, the gill slits found on human embryos and in many fish are evidence of a common ancestor precisely because they have no adaptive utility in human embryos. The term vestigial carries the double meaning that Darwin intended. Vestigial traits are useless to the organism and they are vestiges of a bygone age. By recognizing they are useless, we see they provide substantial information about the past. Now this is the point. It's true that you can't just look at similarities and then say, right, that's down to common ancestry, that's homology. You have to do things that are more sophisticated than that. Let me give you another piece of evidence to show you how this is done, okay? So let me go back to my little presentation here, okay? So, let's go to something called amino acid functional.
Wait, hang on. Let's stick to Elliot Sober's point, because I don't want you to make a point and move on.
But it's important.
No. Wait. But that's a separate point.
Hang on.
Listen. I'm here all day. Let's deal with that point. How does that undermine?
I'm not here all day.
Well, I am.
Okay.
So how does that undermine the point which I made about him?
Because you misquoted Elliot Sober.
How?
You misquoted him because what Elliot Sober said was you can't just look at similarities and then say, okay, that's down to common ancestry. And I agree with that.
But
what he said afterwards was that if you look at similarities in functional things, that might be down to common ancestry, might not be. But if you look at similarities in non-functional things, then you can conclude common ancestry. That's what Elliot Sober says. Elliot Sober is very clear.
Okay,
you can
okay.
conclude
Wait,
common ancestry,
hang on
and you're quoting him to say that you can't.
It's a really strange situation where somebody says you are misquoting this person, and then when they are explaining how you're misquoting that person, they misquote them themselves.
How did I misquote him?
Here's exactly what Elliot Sober said. He said, the idea that humans and chimpanzees have a common ancestor, the idea that they must have a common ancestor because they're so similar, and the idea that humans and mushrooms must have independent ancestry because they're so different, both of these are naive because they are based on a probabilistic framework, and within a probabilistic framework there is no must in either case. He is describing homology as an assumption, and that assumption of homology fits into a probabilistic framework which also has other assumptions, such as a mechanism of natural selection, which also has other assumptions such as gradualism and vertical gene transfer and so on and so on. So what I said there, he did not undermine by what he's describing later. Elliot Sober, what he's basically saying is that you cannot claim human chimp ancestry is true, literally is a must, because it's still based on a probabilistic framework, which is exactly what I was saying.
Okay, let me respond, right? What Sober is saying is that you can't just look at the similarities and conclude common ancestry. I totally agree with that. No one is doing that. Let me show you how we do this, okay? Here's another piece of evidence, okay? This is called amino acid functional redundancy. So if you look at amino acid sequences, right, you can have different amino acid sequences give you the same functional protein. It's a bit like, imagine if you get dealt some cards, right? Imagine you get dealt 4 aces. Okay, I've got a strong hand here, right? Doesn't matter what order the aces are in, does it? Doesn't matter whether you've got the ace of diamonds first or the ace of spades, makes no difference, right? So similarly, in proteins, you can have different sequences of amino acids give you the same functional protein, okay? So there are proteins called ubiquitous proteins that are shared throughout all living things. So an example is something called cytochrome C, okay? So in cytochrome C, you can have different amino acids and they will have the same function. How do we know this? Because genetic engineers have actually taken the cytochrome C of humans, which has a different amino acid sequence, put it in yeast and found it works just as well, okay? So there's no reason for the amino acid sequence to be the same unless I have common ancestry. So here's a table comparing amino acid sequences, right, of different species. And what you see,
homology.
What you see is that the humans and chimps, the amino acid sequence of cytochrome C is absolutely identical. Not a single difference. Hang on, if you can just not stand in front of the camera. Yeah. Now, as you go to other species, other mammals, they're pretty similar, but not identical. And what evolution would predict is they get less and less similar as you go to less and less related species. So if you go to yeast, you see very little similarity. Hang on, let me finish.
You're making...
Let me finish, right? Now, the point, and it's the point that Elliot Sober himself makes, is that if you look at something that's functional, if you just looked at, are the proteins similar? Yes, you cannot derive common ancestry for that because they're functional. But the amino acid sequence is not functional. You can have a huge number of amino acid sequences, right? Now, what's the problem? Suboor says it's based on probabilistic reasoning. That is not even a serious objection because you have to say, what are the probabilities, right? I mean, if you say this thing has 1 in 2 chance and this thing has 1 in a zillion chance, they're not the same, right?
Okay.
Let me finish the point. Right. So what is a probability? This was done. They calculated the probability of this pattern happening if evolution is not true. And what they said was the probability of that happening if evolution is not true is 1 times 10 to the power 93. So when he says it's based off probabilistic
atoms in the universe,
more than the number of atoms in the universe, right? So when he says it's based off probabilistic reasoning, that's not even a serious objection because the size of those probabilities is so big, you'd have to be crazy not to think that that's true.
Okay, so tell me this.
Yeah.
Since you're saying let's go by probabilities, the first point which I want to highlight here is earlier you were speaking about it being a fact, it being true, and now at least with evolved in the sense that we're now speaking about a probabilistic framework and we're speaking about assumptions.
It doesn't mean
Well,
everything.
So now let's go to disputes.
No. Okay,
Fact
hang on,
it's
hang
a
on.
probability doesn't mean
So
everything.
very probabilistic does not mean it's not a fact.
I didn't interrupt you for almost like 5 minutes.
All right, that's fine.
So let me just deal with some points. So the first point is this. Earlier in the conversation, and we have the video here, you weren't speaking about actual probabilities. You were saying it's true, overwhelming evidence, blah de blah de blah. Okay, now we've got to a point where you're now speaking about a probabilistic framework and you are admitting homology, because when you're speaking about look at this and look at this and look, therefore it's similar, you are basically accepting homology as an assumption within that. Now, when you take a particular quote and you say, look, you have this particular sequence and you have this particular sequence, and the chances are